also related to the release of our first images from biomass. And we have with us here on stage Simonetta Cheli as the Director of Earth Observation and Florence Rabier from ECMWF. Of course, well known, our DG Director General Josef Aschbacher and the Director of EUMETSAT, Phil Evans. I would just suggest we open the floor for your questions. We're very excited to see what you have to ask. And we have also our experts on the Earth observation side to answer further your questions. So please, the floor is yours. Gaia has a microphone, or I can do it from here.
Thank you. Congrats. Antoine Meunier, lachroniquespatiale.com. Congrats for this first image, but my first question will be, what does this first image from biomass teach us?
Thank you for the question. It shows us, it's actually it's a first set of images. You will see, we will publish a web story. The first one is on Bolivia. It shows us the way the land use is organized in terms of agriculture exploitation, but it shows us also the differentiation between wetlands, rainforest, forest, and also the type of forest. So for the moment, it's an image that gives us the feeling of the variety of the forest. Of course, it's an image that will be worked with the additional data on the ground to validate. It's an image that it will actually be coupled in the next 18 months with a 3D tomography vision of those tropical forests. That's what is planned with biomass. And then a subsequent interferometric phase, which will last for up to the next 5 years, which means this image gives us the feeling that you can understand much more about tropical forest, not just in terms of how it's organized, how it's differentiated, but also how it's differentiated in terms of 3D vertical view of that forest. And that is really what the P-band radar allows us to do. So in terms of impact and effects, the effect will be that we will know better how this tropical forest is managing to absorb CO2. And you know that in tropical forest, basically you have the leaves that absorb 1%, 75% the trunks, and 25% the roots of that tropical forest, the CO2. So you will also differentiate among different areas of tropical forest. And the other images will also show, for example, the Gabon forest and some Southeast Asia forests. And that will be really the type of differentiation in terms of novelty of information, not just the coverage, but really the different elements of the trunk and functionalities.
Maybe I add something, and this is not in my function as DG, but in my previous job as Earth Observation Director and working with radar data for many years. If you compare the Sentinel-1 data, which are C-band, the wavelength is a few centimeters, while the P-band is much longer, and therefore the waves are penetrating through the upper layers of the canopy. So you don't see the leaves or the top of the canopy, you really see all the way down to the trunks, and therefore the biomass, that's also why the mission is called biomass, because you can measure actually you get a return signal from the biomass, that means from the trunks, and the big structures of the tree, of the biomass, and therefore you get a signal under the canopy and not just from the surface as you would get it from other sensors. So you look into the forest.
Further questions? Yes.
Thorsten Krenning, Spacewatch Global. You mentioned in the release of the data that not everything could be tested on ground. So what surprised you most, and what is this additional add-on that you couldn't test before, and which?
Maybe we should ask
the project manager.
Project manager, exactly. Come up here and introduce yourself.
Fearing is my name. I was the project manager of Biomass. So what Josef just said, when you have an optical mission, you fly over it, you see green. You see maybe when there is no forest, when there is deforestation, but you have no chance to see how much biomass is in these forests. And that is our biggest aim. We fly over it, we want to see how much carbon is stored in the forest. You need to see the trunks, the big ones, and that is the long wavelengths that we need to do that. We see to the ground. We can estimate how much is there. We fly over it. It takes about 9 months to take a total map of the globe. When we come the next time, we see what has changed. How much carbon that is emitted by burning fossil fuels has gone through the atmosphere into the forests, how much has been cut off, how much has been degraded, and we can see the balance helping the carbon cycle and climate models.
What is the difference to hyperspectral then?
Hyperspectral is you don't penetrate, you see green. You have no clue what is beneath the leaves.
Yeah, hyperspectral is in the optical domain. It's optical and in many cases near infrared, while this is a radar. That means it's much longer wavelengths, and therefore you really have a completely different behavior of the electromagnetic wave with the object, that means the tree in this case, and the signal you get is a very different one. What you get from hyperspectral is the reflection of sunlight, which is the source, the energy source is the sun, and you get a reflection of it. While here in the radar, you have your own power source on the satellite. The wave that's sent out in P-band is interacting with the canopy, or with the, not with the canopy, with the trunks, that means the biomass. Some of it is reflected back, some of it goes in all places. Some of it is reflected back. The part that is reflected back, you capture, and therefore you get a structure, and information about the structure of the vegetation. Also, maybe it's important to know this is the very first time that a P-band radar is flown in space. Absolutely fantastic, and of course we highlight the biomass aspect of it for tropical forest, but you could also look, we will look, and I'm looking forward to see the images into very dry areas, for example in deserts or very dry areas, soils, where you can actually look into the soil and happens what's underneath. So really interesting sensor. We look forward to what's coming out of it.
If you're still here on Wednesday, that's the presentations.
If there is water will block it. So water acts like a mirror, but if it's dry, you can penetrate actually quite into it.
Okay, we have another question over here.
Thank you, Daniel Chrétien from Futura Science in France. I have a question for you, Josef, Dr. Aschbacher. The war threatens the world, or this time of war threatens Earth science budget generally, as we can see in the NASA budget for 2026, with a 60% reduction from the Earth science and climate science budget in NASA. What is the future of civil and scientific EO? Is it safe today, and particularly in ESA? At ESA, how will it cohabitate with the ESA contribution to the European Resilience from Space project?
Yeah, no, that's a very, call it a political question, or a very strategic one. So for those who are not so deep in it, maybe I just say one word what you're referring to. Thank you, Daniel. The White House has published on the 2nd of May what was called the skinny budget, and about 4 weeks later, the more detailed budget of the White House proposal for the next fiscal year 2026 budget. And this proposal, and I underline the word proposal, is proposing cuts of NASA in the order of 25% overall, but on the science part of about 50% across the science directorate. If I underline proposal, that means this is the proposal of the White House. It is now being negotiated with Congress and the US, I would say, system. We expect, or this is the normal procedure of budget negotiation in the US, that the budget will be agreed and then signed off by the president sometimes in fall. There's no firm date, depends on when the US system agrees. And then once the budget is agreed and signed off, then you have a new budget. So today we have a proposal, but not yet a decision, and this is why I'm saying that. But if the proposal comes as proposed, or with maybe some modifications, what is the impact on science? Yes, it is quite significant, but let me say it's quite significant on the science budget of NASA, which will be reduced by 50%. But interestingly, although there's a small increase of 10% proposed for exploration, it will hit Europe harder because the exploration part, they're reshifting some of the, or proposing to reshift some of the priorities. I can be more concrete. Mars Sample Return, which is a mission where we plan to go together with NASA to retrieve samples and bring them back to Earth and analyze them. That mission is proposed for cancellation, and that of course has an impact because we are a strong partner. The other large impact is on what is called the Gateway, which is an orbital station outside the moon, which is there to prepare the return to the moon by astronauts, so as an interim station, but also a stop in interim to have astronauts coming to the moon surface. The Gateway is also proposed to be cancelled, and there we are building a lot of hardware. That means the station, more than 50% of the station is made in Europe by ESA. So if that element would disappear, of course, there would be a huge impact. Another element that would impact us a lot is the Artemis flights. Artemis 1 has been flying. Artemis 2 is expected to fly soon. Artemis 3 is also expected, but then the proposal foresees the cancellation from Artemis 4 onwards. And we deliver the European service module of the Orion capsule. The European service module is the element that provides power, oxygen, thermal control of the Orion capsule where the astronauts are sitting or are going to the moon, first to the Gateway and then to the moon surface. So all these are elements where Europe is very heavily connected and interacting with NASA. And again, if these elements are being proposed for cancellation, we will be significantly impacted. We do not know whether this is the final decision. As you might have heard also, there's a lot of lobbying and discussion going on in the United States by industry representatives, politicians in particular. So the proposal might be modified along the way, but that would be the case. Now coming to science, we have in the US, the science budget is actually covering both space science, that means missions to explore the universe, but also Earth science. And the impact on Earth science, which is Simonetta's responsibility, is relatively small compared to other parts. So there are two missions in particular, Central 6 and Crystal, that might be impacted. But that is, yes, there would be an impact, but I would almost say that is manageable. Of course, there will be small financial impacts on this. On space science, it's a little more severe in terms of impact. We have 19 missions where NASA interaction or let's say elements are required. 16 of the 19 will not be impacted, but 3 of them will be. Well, let's say 16 of the 19 we can manage, I would say with moderate consequences. But on 3 of them, the impact would be more significant. LISA, Envision, and New Athena. And on those ones, we would, of course, need to have contingency measures. So it's a bit of a long story, but just to say that this is work in progress. It is something where we, of course, work with partners. My mitigation measure, and this is something I discussed with the member states just 2 weeks ago, is that I propose, first of all, to maximize the utilization of our funds in these programs. If we have to redirect them, obviously we will come out with new proposals. This is all work in progress, which I cannot elaborate right now. But in short, I would certainly look to reinforce our independence and our autonomy, make sure that Europe has some of the technologies that we need to have on our own. That means we develop it with our industry. In short, I would like to come out of this crisis, if I may call it this way, which is not imposed by us, but by other partners. I would like to come out of this stronger, not weaker, by strengthening the effort of Europe. And this is all part of the proposal I'm preparing right now with the member states towards the ministerial. So yes, there's a lot happening, but I think it's a bit like in defense, a wake-up call for Europe to become more independent and stronger. It happens also in space, and I think we have to respond to this in a clear way and make Europe more self-reliant and independent.
If I can complement then to the DG, what he just said about the opportunity for Europe, not impacting too much on the hardware side, the Earth observation mission. The ones that were mentioned are Crystal and, of course, Crystal B, first of all, and Sentinel-6C in the context of the proposed budget cuts. But there could be quite some impact in the collaboration, which is the Earth science collaboration that we do have with airborne campaigns, calibration, validation, data exchange, preservation of data sets, and product development. And this we don't yet know. We are assessing and we are working. We discuss with NASA. We keep track of what's happening. But I think overall, in terms of the proposals which are going on the table for the ministerial, it's a great opportunity overall for Europe to strengthen the role on everything we're doing on climate variable, environmental, and sustainability overall. Same is, for example, if there is a disengagement, which apparently is the case from USAID collaboration, water management, better resources management overall, collaboration with partners like Africa, those could be strengthened through the current proposals that we have on the table for ministers.
And my second question was about the cohabitation of the future EU budget at ESA with the contribution of the European Resilience Fund Space Program. Can you make sure that it will not impact too much scientific missions to collaborate with the European Commission with that?
Yeah. We need both, if I may call it this way. So a strong Earth observation package. We have a very solid proposal that we are preparing right now for the member states. In addition, as you mentioned, we have the ERS, European Resilience from Space proposal, which was adopted just 2 weeks ago by our member states. It's a very ambitious one, ambitious in the sense of the financial proposal that is made, which has actually 3 components: an Earth observation component, a navigation component, and a telecom component, because it is a system of systems, and I really insist on that. Has a different nature. It's not a classical Earth observation program. It's more geared towards resilience and security, and therefore also we are aiming at in some countries to see whether funding from ministries of defense could contribute. If that is the case, and we are in discussion with some countries which are preparing for that, they could account these contributions to the ESA program against the NATO threshold, which we have just heard this morning will be increased to 5%. So therefore, the contribution to the ESA program, especially ERS, but also others of dual use, could count against this 2% threshold, which I think is quite of interest for those NATO members, or for those countries who are NATO members.
One more question here from the front row.
Yes, Antoine Meunier again. Back to biomass, we understand that the P-band is the key, but will it become the key for upcoming EO missions? As we can see through the...
Maybe you want to say something, Michael, on the relevance of P-band and future missions, but a very good point. I can then respond if needed.
Yeah. As you know, Biomass is in the Earth Science group of explorers, and the explorers are there to build new technologies, new missions, new ideas that have not been there before and that only public organizations will do. So what we do is we try something totally new, see how it works, what is the benefit. With already from the start, we select missions that have the potential to become observational ones. A very good recent example is Aeolus, the wind mission you probably know, will be built now in Aeolus 2. So that several from the other explorers, they went into into application missions in the Sentinel family, and that is the idea. So we will now see, we are at the early stage, we will see how it evolves and works. There's huge potential, and in the coming years, then decisions will be taken whether to continue.
Okay, but is it a good use for to explore through the ice, through the mountains, maybe?
These are secondary objectives: the desert and the ice, and there will be many more in the coming years by the scientists. But don't forget, the primary objective is the biomass, is the forest. It's a forest mission, and there is no other way. You can do always many things with different tools, but to get the biomass in the tropics, at the moment, there is only one way, and that is a P-band radar. With smaller wavelength radars, you saturate at the very dense forests.
Antoine, maybe one comment on how ESA works and how this biomass mission fits into our overall way. As you know, we are developing completely new technologies that are not flying yet. It's 2 things. One, and this is applying to the Earth explorers in particular, we ask scientists to ask questions that where they need an answer which are really challenging to do. So it's really a scientific challenge that we get. And then we look at technology, whether technology can answer them, and we fly technology that has not been flying before. So it's completely a first. It's a first time that worldwide that we have a P-band radar, and this is exactly the way also how we see that. If you have seen the antenna in the pictures before, absolutely challenging in terms of technology. That's why it is such a special mission, and to prove the concept that it works and that it is I would say, technologically sound, and we get good experience is a very important element of our of ESA's work. And then, as we have seen in quite a few cases, some of these scientific challenging missions become operational, like in Copernicus. Some of the Earth explorers have become Sentinel missions, and I think this could be a route. I don't want to preempt future discussions, but certainly this is something that that is excites a possible way.
We have one more question from the back row, and then you're next, and one more here.
Hi, my question would be, as I read before the launching of the satellite, you said that there wasn't reliable information about the biomass and how much carbon dioxide had the forest. So with the new images, could you explain a little bit what new things have you learned about that, if there's new data? And the media outlet is EFE.
Let's pass the question to the mission manager, the scientist.
My name is Klaus Schippold. I was mission scientist for some time for this mission and now mission manager. So far we had no possibility, especially to observe tropical forests, because they are very dense, they hold a lot of biomass. Tropical forests are also the most important forests. They not only hold most of the carbon that we have in space, it's also the forests that are under the biggest threat. So we are losing thousands of square kilometers of forest every week. So this is really the part where we want to observe and where we have no observations on ground. For example, in Europe, in North America, we observe forests on the ground, so we have a lot of information. This is not the case for the tropical forests. So this mission was specifically designed to observe these tropical forests, and there we hope to get the biggest insights of these missions, because it's the first time where we get these observations wall to wall, so covering the whole globe.
Next question, please.
Yes, my question would also be, is there also a possibility to cover like European North American forests in the future? And the second one is, what do you expect of analyzing deserts and these extreme environments?
Maybe I answer to the first part and Klaus to the second part. No, we cannot observe over Europe and North America because of military radars that have priority. Maybe a bit of an explanation to that. The P-band radar with its 70 centimeter wavelengths is very susceptible and very good to detect objects that have same order of magnitude of size. And missiles are not so dissimilar in that sense to big trees. So the military came up with these missiles, and we are secondary users and secondary objectives. But this was known when the mission was selected. There were articles in the press after launch that were a bit indicating that it was not so, but it was known when the mission was selected. Scientists said, we have good forest inventories in Europe and over in the US. We don't need it. There is nice plots where you show, where we show where there is knowledge versus where there is a lot of biomass in the forests. And where there is a lot of biomass in the forests, the knowledge is very, very poor. Vice versa, in Europe and America, there is not that much density in the forests, but we know basically every tree.
So the second part of your question was targeting the secondary objectives of this mission. Of course, we can not only penetrate into forests, we also penetrate, for example, into dry desert sand, and we can look on the underlying geology, and scientists use that to study paleoclimatological features. So you see riverbeds, old riverbeds that were maybe flooded millions of years ago. So we have not only a very innovative mission that looks into the future, we can also look back into time and learn from our past. So this is very exciting. And Biomass has the biggest penetration capability in this sense. We can also look into ice. So we penetrate several meters into ice. We can look at if the rock bed is not too deep in the rock bed of the ice and the grounding lines of the ice shelves. We can look on sea ice. So we also hope to get a lot of knowledge over these areas, especially in the Antarctic zone. And finally, there's the big unknown. So we have also some ocean windows, for example, where we look on the ocean, where we don't even know what to expect or what we can see, but because it's the first time we look at it at P-band, scientists came to us and say, maybe you should switch it on there as well, so we just get an idea of what we could learn from this sort of data. So there's a lot of things beyond forest that we will also explore.
Thank you. We have the next question here. Please introduce yourself.
Hello, I'm Karl Urban for the German public radio station Deutschlandfunk. My question is more about the long-term goals or achievements of a mission like Biomass. I mean, it's about all those gaps in climate models, for example, and in the mass of trees. But could you say what are your hopes or ideas how missions like this could shape policy globally? I've heard from a government who claimed not to be so much interested in results from the mission because they are interested in selling tropical wood. So do you think missions like this and results from science can help shape policy?
You want to start or shall I?
Yeah, on how this can shape policy, and we have seen this not only in biomass, or we will not see this only on biomass, but on many cases. It's happening all the time that when you provide information, then that information is being utilized in a very good way, or in a very helpful way, at least for the sake of our planet. Climate change is the best example. For climate change, we're having sentinels, we have Earth explorers, we have meteorological missions that are providing incredible data. I would almost say without those satellite observations, you would not be able to, certainly not to understand, to model, and to predict climate change as we do it today. And biomass is one element of this, because it measures one parameter that is very crucial, not well known, biomass, that means in tropical forests in particular, which play a huge role in the carbon cycle, in the global carbon cycle, in terms of absorption, emission in case if it is cut or burned. So all this is really important to understand the overall Earth system that we are measuring and we are observing all the time with our satellites. Now coming to your policy implication, yes, of course, this information will be seen by decision makers, politicians, by the general public, and they will create, or this information will help shaping future policies, which is a much larger part of the conversation in society that is happening, that needs to happen, and therefore I'm actually very happy and very proud that our data provide information in order to make these policy decisions to work and to happen.
Maybe to complement, just to say we are supporting all the climate variables, 27 out of the UNFCCC variables, which are over 50, with data sets from different missions, scientific missions, but also Copernicus mission. We are building a new satellite, CO2, which is dedicated and has been conceived to support the implementation of the Paris Agreement in terms of monitoring CO2 of anthropogenic nature. So there's a really close connection between the support that you can provide from ecosystem and data sets to policy. Another example is IMEO, is the International Regulatory Framework on Methane Monitoring. We work very closely with DG Clima, the General Director that is implementing the climate policies to support them on greenhouse gases monitoring, on land monitoring, using satellite data and demonstrating the relevance of that.
Next question from you, please, Philip.
Philipp Adelt, German Public Radio. The new satellite is a good example that many of the Earth observation efforts from Europe take place in other parts of the world, not in Europe, for obvious reasons. Now we have a new African Space Agency. So I was wondering whether every continent or every landmass, isolated landmass, let's call it like that, needs its own space agency, or whether more cooperation would not be better. And to continue this question, to elaborate it more, how maybe you have concrete examples how the cooperation with the African Space Agency will be, or maybe even concrete projects already that you could achieve together.
And the African Space Agency has just recently been formed. You may have followed it, and actually they have been really looking at ESA, the European Space Agency, as a model, because we have 23 member states, and Africa they have more. But how can you bring countries together in order to have a space agency of a regional nature? Coming to your point on how this interacts, we interact with them very much. We are working with all the space agencies worldwide. We have about more than 300 cooperation agreements with partners across the globe, including the African Space Agency and many individual space agencies in Africa. There are several countries who have their own space agencies, so there we are very well networked. But the beauty of space is, especially on Earth observation, that the satellites go around the globe all the time, and therefore they take images or data from the whole globe, and therefore it's easy to share those data with partners around the world, except of course for the geostationary ones, which are over a certain point. But for the polar orbiting satellites, which are most of the satellites you have seen, they're going around the Earth continuously, and therefore it's very natural that we share. In fact, we have an open data policy. That means all the data that we measure and that we deliver are free and open for anyone around the world, in Africa, in America. So this is really a service of Europe, if I may say so, to the world to provide this information for everyone.
Can I complement? Maybe there is this new project called SIWA, for Space for Early Warning of Africa, and our 3 organizations are partners in this. It's a European project, and it's really working with actors in Africa to co-develop together the tools for early warning based on space observations, but also different tools, including AI, machine learning, and the technical tools in order to do short-range forecasting until climate ranges. So, I mean, there is good collaboration with Africa.
Thank you. We have one question here, and then I would say a final question.
Just add something.
Excuse me.
Can you hear me? Yeah. There seemed to be sort of something in the question that potentially the creation of regional space agents was somehow in opposition to global partnership. Actually, I think it's the other way around, that any sort of intergovernmental organisation is a tremendous enabler of international cooperation. You see it with ESA. But EUMETSAT is a European-based organisation that gives us, tremendous power and influence, and helps build international partnerships with operational organisations. So I see the things as hand in hand, not as in opposition.
Sorry again.
Right.
Next question, please.
Hi, this is one for pretty much everyone. So I'm Daisy Dobrevich from space.com, and we're going to go back to the biomass images, because that first one was pretty breathtaking. So I just want to know what each of your kind of initial reaction was when you first saw the images. Was it relief, I suppose, for some of you, or general excitement?
I start?
Yeah.
A mix of feeling. As we said at the beginning, we could not test everything on ground. So when we saw the first image, we knew everything was working as we planned. So it was a big relief, of course. But then it's a lot of excitement, because you see all these different things you didn't even expect to see, and it's really amazing. Every day a new image comes in. It's amazing. You see something new. That's really beautiful. That's the beauty of our job, I think.
Somebody else wants to comment?
Yes.
Michael?
I was in ESOC in Darmstadt in our control center the day when we switched on the instrument, and there was the team from industry with us, the industry team from Airbus Friedrichshafen, who have built the instrument. And on the very same day, we got the first image. Did not look like that what we have shown today in color and so on. It was a grayish picture, but I remember still the chief engineer of that industry team. He said, "Wow, I see total black." And what he meant was that picture was taken over the Amazon, and on the river. A feature of the instrument is that when it sees water, it doesn't reflect. And he said, I see black, that means there is no noise in the instrument. And that was a wonderful moment, because then we really knew that, okay, there are many other parameters. But he said, okay, the instrument works well.
Maybe I can also add that as we are running the Copernicus Climate Change Service, very excited. This is not going to come anytime soon into our processing, but any development in research will then feed into something that will come into these highly authoritative and informed data sets that are produced by the partners. So super exciting for the long term.
Yeah, I also say it was excitement, of course. I saw the image a few weeks ago, and we kept it quiet until it was really well processed to be shown. But it was also relief, because this is a very complex mission. So I knew from the teams how much we had, worked in terms of getting to their development of the P-band radar, but also the reflectometer. I mean, it was complex. It was even just deploying it, this 12-meter antenna was something very challenging. So I was very much aware about the complexity of this mission, and such a relief. And also I found it extremely beautiful. And I think it shows the beauty of our Earth and what we can do to protect it, which is essential, even if this is part of the contribution.
Thank you. We have one more question here.
Thorsten Krenning, Spacewatch Global. Direct question to Florence. Even you just answered it partially. Is there a value add of the biomass data for you or the European weather forecasting?
So I was talking more about climate monitoring in the first answer. We have an Earth system model for weather forecasting, but it's very crude compared to, so we couldn't yet use this sort of really precise information. So the way we describe vegetation is at a level that is it's shameful compared to what is being done in here. Now, where I get a lot of hope, though, is because all our processes are physics-based and they are complicated to run in real time. But with the advent of AI and machine learning, we can see already that we can push the limit of what we can do with advanced Earth observations. So I think with that one, we could see maybe a way of integrating these more advanced Earth observations in the future. So exciting, but not for tomorrow.
Thank you very much. I would also, looking at the time, suggest that we come to an end. Of course, also our panelists are available for questions here in the first two rows, and also individual interviews can be requested, and our ladies will take these requests and try to organize a slot. I know Simonetta has to leave. I'm not sure about you all. And I thank you very much for attending. I thank you very much for your interest and all your questions. And I conclude the press conference with this. Thank you very much.